Welcome to all of you. I hope all of you are doing well. A very good morning. I hope all of you are safe and sound at your home. Up to now we have completed chapter 13.2. The next topic that I am going to start with your permission and with your concern is Bayes theorem related to probability. I hope all of you are ready for the mathematics classes. So get ready. I'm going to start the new topic based on probability, which is based on conditional probability. I can say is Bayes theorem. Now this Bayes theorem which help us to solve a problem based on some conditions. So the concept that is needed to solve this Bayes theorem problems is conditional probability, which I have already told you in the previous classes. I hope all of you have reminded that. If you have forgot, try seeing my previous videos, and if you still have doubts, you can contact me also. So without wasting any time, I am going to start. Please see carefully. Bayes theorem. It describes the probability of occurrence of an event related to any conditions. So if I am calculating the probability of that such event which is based on some conditions, I have to use the concept of Bayes theorem. This is also considered for the case of conditional probability. So the Bayes theorem is totally dependent on conditions, that is conditional probability. For example, if we have to calculate probability of taking a blue ball from the second bag out of 3 different bags having ball of 3 different colors. So there are 3 conditions here. First we have to calculate the blue ball from the second bag. We have 3 bags each carrying balls of 3 different colors. So for that particular case I am going to use Bayes theorem to simplify or to solve our problem. Now in simple language, in simple way, we can write probability A conditional B is equal to probability B conditional A multiplied by probability A divided by probability B. This is the formula we are going to use for solving the question related to Bayes theorem. Now to make this theorem understand in a very proper way, we will have to solve some examples which I am going to tell you now. Please see the examples very carefully. I am going to tell you one question based on Bayes theorem. The question is full of some conditions, so we have to read out the question very carefully. So let's start. Bag first contain 4 white and 6 black balls, while bag 2 contains 4 white and 3 black balls. So in total there are 2 bags each containing 2 types of balls, black and white. One ball is drawn at random from one of the bags and it is found to be black. We have drawn one ball from any of the bags and it is found to be black. Now we have to calculate the probability that it must have been drawn from bag first. So in this question there are 2 bags each having equally outcomes of taking out for drawing the balls. So let E1 and E2 be event of choosing a bag. The probability of both E1 and E2 should be 1 by 2 because there are 2 bags and the conditions for each is equal. Also let the event A denotes taking out or drawing out a black ball. So A event of drawing a black balls. Now this represents drawing a black ball with condition of first bag. A conditional E1 means we are drawing black balls with the condition that we have first bag is, as we have 6 black balls and total number of balls is 10, so 6 by 10. This is A conditional E2. We have 3 black balls with total of 7, so this is 3 by 7. Now the question is saying that the ball is drawn from bag first. This states that ball is black, bag is first. We have to reverse this condition that we have chosen the first bag and we have taken out the black ball. So this is probability E1 conditional A. For this what we am going to write here, all the related probabilities of A and E1, that is probability A conditional E1 multiplied by probability E1 divided by sum of all probabilities, sum of all the events. So by simplifying it, we get the answer 7 by 12. So we have to reverse the condition of conditional probability here. What we have applied first, A by E1, that is A conditional E1, but in final answer we need to calculate E1 conditional A. So for that we are going to use the concept of rule of multiplication also. In this way we can solve the problem of Bayes theorem. I am going to tell you one more question to make your concept more stronger. Now we are going to see one more question related to Bayes theorem. The question is, a man is known to speak truth 2 out of 3 times. That is, out of 3 sentences, he speak 2 as true and 1 as false. He throws a die and report that the number obtained is 4. He throw a die and he said that the number came out as 4. Find the probability that the number obtained is exactly 4. Now this is based on conditions, so we are using the concept of Bayes theorem. So let A be the event that he reports 4, E1 be the event of obtaining 4 when he throws the dice, E2 is the event for complementary event, that is not getting 4. So probability of E1 is 1 by 6, out of 6 we have only 1 4, that is 1 by 6. Complementary events is 5 by 6. Now A conditional E1, that is he reports 4 and 4 is obtained, is 2 by 3, because out of the 3 sentences he said 2 is correct. A conditional E2, that is he reports 4 but the 4 is not there, it is complementary event, so it is 1 by 3, because out of 3 1 sentence is false and 2 sentences true, so that is 2 by 3 and this is 1 by 3. Now it is exactly 4, so we have to reverse this condition, E1 conditional A, and all the related terms, all the related properties of E1 and A should be placed above as numerator, and the whole term in summation should be in the denominator. Applying this, we get the solution 2 by 7. I hope you understand the concept of Bayes theorem. I am again recalling you. The concept is based on conditional probability with some use of rules of multiplication, theorem of probability. So you try solving examples of all related to this Bayes theorem, and you try solving problems of 13.3. If you find any doubts, you can call me or you can message me for that. In the next class, I am going to explain you about Bernoulli trials and probability distribution. Hope all of you understand. Be safe and be sound at home. Complete your pending work. Thank you.